Hello everybody and welcome back. Root Beer here with question number 18 on the 2002 Cayley competition. Alright, hopefully you've clicked the link in the description and possibly on one of the previous videos, downloaded a copy of the contest and tried the questions, in particular 18, for yourself. I'm going to go through 18 now. And what does 18 say? In the diagram, triangle ABC is isosceles, with AB equal to AC. So they tell us which two sides are equal. And AG is perpendicular to BC. So AG is going to run completely down the middle, splitting this thing in half. Point D is the midpoint of AB, and point F is the midpoint of AC. And E is the point of intersection of DF and AG. What fraction of the area of triangle ABC does the shaded, we got a triangle here, AEF, does this shaded area represent? So we have choices of a 12th, a 6th, a 4th, a 10th, and an 8th. Okay. So, the quick way to do this is to say, oh, well, I know what happens when we do midpoints. If I do midpoints, this triangle ADF is going to be a quarter of ABC. And since it's isosceles, this line AE splits the smaller triangle in half. So AEF is a half of ADF, which is a fourth of ABC. So a half of a fourth is E1/8. So that's how you do it quickly in your head if you were accustomed to this sort of thing. All right. Now, let's write it out a little slower and talk a little bit more about it, in case this is maybe your first time seeing a question like this. So let's draw our picture. That's isosceles enough. And we have AG. And we have midpoints that we connect up. And we are told those. Okay. The first thing I want to notice is that ADF is also isosceles. I think that's a good thing to note. I want to say, well, AE splits it in half, so we get this right angle here. But what can I do here? Okay. Notice also that DF is parallel to BC. Why? Well, if we drop these perpendiculars down here, we're going to get the same height here. Yeah. So because it's isosceles, we know that this angle here at B and this angle here at C is the same, which means that these two triangles here are going to be first similar, but then because they have the same hypotenuse, they're going to be congruent. And that means that they're going to have the same height, which means that D and F are both the same distance away from BC. And that means that DF as a line is the same distance away from BC. Another way of saying that is parallel. And now I can conclude that AEF is 90 degrees. And that AE splits ADF in half. So our shaded area is 1/2 of triangle ADF. Okay. So we changed it from, we don't quite have the ratio of our shaded area to ABC, but we're working on it. We have this smaller triangle ADF. What do we want? I want a congruency here. No, not congruency. I want similarity. So notice that since DF is parallel to BC, then ADF is equal to ABC. But we know that that's also equal to ACB, which is equal to AFD, which makes sense because we already noted that they were isosceles. But the point is that we can now introduce our red angle here and here. So that tells me ADF is similar to ABC. Okay. So now we're starting to, we have our shaded area in terms of ADF. It's 1/2 of ADF. And now we're starting to get a relationship between ADF and ABC. AB is twice AD. And so that means that AC is going to be twice AF. And BC is twice DF. Twice DF. So our lengths are doubled. So if we had, if we call this H, then this height here is going to be 2H. And DF, we call that the base. We're going to have twice the base. Now the area of triangle ADF is 1/2 base times height. So the area of triangle ABC is 1/2 twice base, twice height. And that's going to be 4 times 1/2 BH. Just 4 times triangle ADF. If we rearrange that, we see that triangle ADF is 1/4 of triangle ABC. And now we can put it all together. The shaded region is 1/2 of triangle ADF, which is 1/2 of 1/4 of triangle ABC, which is 1/8 of our triangle that we were talking about. So 1/8, and I think I said that was E, but let's just double check. Yep, E 1/8. So there was the quick way I did it at the very start with a nice verbal explanation. If you see these things, midpoints of triangles, you start thinking, okay, the smaller triangle made with the midpoints is going to be 1/4 of the total area. And so that's the sort of thing that jumped into my head immediately. And I was able to quite quickly mentally process it through and get 1/8. But now we've actually shown our work. In case you're new to this sort of thing, we talked about similar triangles, and we were able to tell, well, AD, we double that to get AB, which means all the lengths in the smaller triangle ADF are going to double when we blow it up to ABC. So that means double the base, double the height, and we were able to work it all out. Okay? So we're going to move on to question number 19 on the 2002 Cayley. We're going to do that in the next video. So join me there. I'll see you guys then.